Scenario 14.3. Suppose a certain competitive firm is producing Q equals 500 units. The marginal cost is 17 of the 500th, and the average total cost is 12. The firm sells its output for $20. If the marginal cost of producing the 501st unit would be 19, producing and selling the 501st unit would. Well, what are they selling their output for? $20. They're a perfectly competitive market. They can always sell one more. So their marginal revenue is equal to 20. Their marginal cost is equal to 19. Since marginal revenue is greater than marginal cost, we produce and sell. Well, what's the profit from that last unit? Well, they sell it for 20. It cost them 19, so the difference between how much they sell it for and how much it cost them to produce is 1, so they increase the firm's profit by $1. The answer is C. Question 12. We're in a perfectly competitive market. Firm produces 40, total cost is 5, it's earning 240 economic. What is the current market price? Well, we know that profit is equal to price minus average total cost times the quantity. So then we have our profit of 240 here is equal to price minus average total cost of 5. And our quantity is 40. So we divide both sides by 40 is equal to price minus our average total cost of 5. That gives us that 6 is equal to P minus 5. So then the price must equal 6 plus 5 equal.
So 5 plus 6 equals 11, so the price must be 11.
OSHA has determined that 100 workers are exposed to a hazardous chemical used in the production of diet soft drinks. The cost of imposing a regulation that would ban the chemical is 10 million. OSHA has calculated that each person saved by this regulation has a value equal to 10 million. If the benefits are exactly equal to the cost, what probability is OSHA using to assess the likelihood of fatality from exposure to this chemical? So remember, each life is worth 10 million. Right? The cost of a regulation is 10 million. So if 100 workers are exposed, then what is the probability that there will be a fatality for being exposed to this? Well, we have the number of workers, 100, times that 10 million, must be equal to the cost of imposing that regulation, which is 10 million, well, if the cost of imposing it saves enough of them, then what's going to matter is the probability that these people get affected by this chemical. So you want to add in the probability times the number of people times the cost of that regulation. And we'll go ahead and solve for P here. Well, we know 10 million and 10 million, so P times 100 equals 1. So then P is just equal to 1 over 100, which is equal to 0.01 or 1/100th. So the answer is B. 14. Highway engineers want to improve a dangerous stretch of highway. They expect that it will reduce the risk of someone dying in an accident from 5.3% to 2.1% over the life of the highway. If a human life is worth 10 million, the project is worth doing so long as it does not cost more than. Well, what is the reduction of death? Death goes down from 5.3 to 2.1. So that means that it improves by 3.2. Since we're saving 3.2% more lives, and each of those lives is worth 10 million, then we just need to do the simple 3.2 times 10 million, which is equal to 320,000. So then we'd be willing to spend 320,000 to save those lives. Question 15. Refer to figure 11.1, which of the following is not an example of a type of good that represents box D. So then it needs to be non-excludable and non-rival, a mathematician's theorem. Once you learn it, it's not excludable, and it's certainly not rivalrous. Anybody else can use it. An uncongested toll road. Is a toll road excludable? Yes, it has a price. National defense is non-excludable and non-rival. Fighting poverty is non-excludable and non-rival. So the answer must be B, an uncongested toll